We have our constructor function in place, allowing us to generate that unique object, and in this case, we've generated 2 of them. What I want to talk about now is not what makes each person unique, but what's the same. And for this, it is going to be a set of methods that are shared amongst all instances of person. So we're going to be setting up a little inheritance. Because you're an instance of person, you are going to inherit certain behavior. There are certain things related to all people, and that is exactly what we're going to end up defining. Now, when we talk about this idea of inheritance, allowing instances of the constructor function some sort of unique shared behavior, what we're really using in JavaScript is known as prototypal inheritance. That's prototypal inheritance. Prototypal inheritance is a form of inheritance, and if you come from no other language, don't worry, we're going to talk about exactly what it is and how it works. Now, if you do come from another language, you're going to have to switch your mindset around just a little bit. For example, in C++, in Java, things might look vaguely familiar, but it actually is functionally different. So we're going to go ahead and figure out how to add a method onto me and person2, both being instances of person. To do this, all we have to do is add a little configuration to our constructor function. Right here, we're going to be accessing the constructor function, and then we're going to be accessing its prototype property. Prototype is an object. On this object, we put everything that we want to share with the instances of this constructor function. So if I want all of those instances to be able to access some sort of method, I provide that method right here. Let's say that we want to call the method getBio. It is going to equal, right here, it is going to equal a function. And we're using a regular function, and we're not using an arrow function because inside of our methods, we also have access to this, which means that we can pull out the individual pieces of information that we actually need. So let's go ahead and set this up like we've done plenty of times before. I'm just going to return our little template string. I'll start off with the first name, this.firstName, with a capital N, then is a period, and before the period, their age, this.age. Now what we've successfully done is we've set up a method that is shared with all of these instances. So down below, we can now change what we do. Instead of logging me, let's go ahead and call me.getBio. I'm going to call getBio for the first one, and I'll also do it for the second one. Then we can go ahead and save our file and actually run it. Over inside of our terminal, that's node person.js. And when I run the script, what am I getting? I'm getting Andrew is 27 and Clancy is 51. So by setting up a method on the prototype property of the constructor function, we've successfully shared it with all instances so they can access it. This is how we're going to set up those methods, things that are the same for all people. Or in the case of some sort of other constructor function, methods that are the same for all instances of a Hangman game. It's important to note that there is no restriction on these values being functions. So if I create a property on the prototype object, I can assign it a value of any type I like, though typically there's not much of a purpose to that. So we're mostly going to see just functions set up on prototype because there's no other static data that we would want to share, but it would indeed work. If I were to set up person.prototype. Then right here, something like location, I could indeed set it equal to a string. I'll use Thailand. And that is indeed going to be shared with all instances of the constructor function. So down below, I could get rid of getBio, and I could access location instead. I'll do it for the first one, leaving the second one the same as it was before. If I rerun the script, we do get Thailand for that first guy, and we're still getting the old message for this one. So now all instances of person, me, and person2 have access to this location property. But once again, that doesn't typically serve much of a purpose. If we have some static data, it's likely going to be configured for each individual person, meaning that it would show up above. This is not something that we want to share across all instances. Let's go ahead and get rid of this not so useful location and set up something a bit more useful. We're going to create a second method for instances of person, and I'm going to call this one setName. setName is going to be set up as a standard function since we are going to access this. Instead of just reading values, we're going to instead take some in as arguments and set values. Now we're going to take in a full name, and it's going to be our job in this function body to extract out the first name and the last name, setting them up appropriately. So down below, we would use it a bit like this. I would use me dot, then I would call setName. I would pass in a name. I would pass in a single argument, a string. I could use something like Alexis Turner, for example. And then when I read off of the individual properties using something like me.getBio, I would expect to see Alexis is 27. So we're passing in one string, but we're going to set two attribute values. To do this, what we're going to be using is the split method available on strings. Split is a great little utility method, and we can explore it over in the browser console. So let's imagine we have the string 1, 2, 3, 4, 5, 6. We call the split method, and what comes back is an array. Now we can call it with no arguments, but that's not particularly useful. If we do so, we see we get back an array with a single item, a string, and the string's value is just the same value we had right here. What's more interesting is when we provide an argument to split. Split accepts a single argument, and that argument is a string. And we can start off with an empty string. If we do this, it is going to break up our string into individual characters. So here, each item in the array represents one of the characters from the string. Now we can also provide other values as that first argument to split. Right here, instead of an empty string, we can put some stuff inside of there. I'm going to use 5. This is going to cause split to look through the string for any characters, 5. When it finds them, it is going to split on that character, meaning that now we're just going to have 2 array items. If I run it, we can see we have 1, 2, 3, 4. Then it saw the 5, so it split on it, and then we have 6. So being able to use these in our code is going to be super useful. We're going to take advantage of that right now by actually setting up the setName method. So const, then right here, we're going to store the array. I could call this something like names, setting it equal to full name dot split, and we are going to split on a space. That's going to take the name Andrew space Mead and split it by the space. So I would have 2 items in the array. The first one would be Andrew, and the second one would be Mead. The same for your name. Now, obviously, this is going to work differently if you include things like a middle name or just one name. So you want to take into account the various input that could come up. But this technique is going to work great for our situation. Right here, we're now going to set values. So I am going to set this dot first name, setting it equal to, we're going to access the names array, and the first name should be stored in the first string. So I'll access by index 0. Down below, we're going to set this dot last name, setting it equal to the second item in that array with the index of 1. And there we go. We should now see that the first person's name was successfully overridden. Alexis for the first name and Turner for the last. I'm going to go ahead and save the file and run it for the very last time in this video. And if I do so, I get Alexis is 27. Notice here I am seeing 27, meaning that the age was preserved. And notice that I'm seeing Alexis and not Alexis Turner. So we were able to successfully split apart the full name, getting the individual components out of it. Now, I was going to include a hangman challenge in this video, but there's one more thing I need to talk about before that challenge is going to make sense. So I'm actually going to push it back to the next video. We'll make that video a challenge video where we spend a bunch of time working on the hangman game. For now, there's one situation I want to talk about, and to illustrate this, what we're going to do is add another item onto the constructor function. In here, we're going to set up the instance property likes. This dot likes equals whatever gets passed in, and we'll set that up as the fourth and final argument for the constructor function. This is going to be an array of the various things you're interested in. So if we're creating some sort of social application, I might pass in an array of my interests. I'm into teaching and I'm into biking, for example. And we could also set up an array of likes for Clancy Turner as well. Let's say that he's not interested in much of anything, so we have a couple of choices. I could go ahead and pass in an empty array. That would get the job done. I could also go ahead and set up a default value for likes. If likes isn't provided, use an empty array. Either way gets the job done. Now what we're going to do to use likes is create an alternative version of getBio that takes those likes into account. So what we're going to do is start off with a little string. Let bio equal, and all we're going to do is grab the exact value we already have. I'm going to cut it out. I'm going to paste it right there, and then I'm just going to return bio. What's a bit more interesting though is that right here in between the two, we're going to use the array method for each to actually go over all of the likes and add something on to bio talking about each individual one. So right here, that might look like this. This.likes is indeed an array. So we'll use its for each method. For each like, we will set up a function. If we have an array of likes, I'll call the individual one a like. And all we're going to do is add on to bio. So I'm going to take bio and set it equal to whatever bio currently equals plus. Then we're going to set up the template string for the next sentence. We'll add one sentence for each like. I'll start it off with a space to make sure there is a space between the period and the new sentence. And then we're just going to use their name along with the thing they like. So right here, we will interpolate this dot first name, then a space, likes, followed by the thing they like and a period. So I'll put the period in there first, then the thing they like under like. Now we could also shorten this. We could use a different operator. If we are taking a string and setting it equal to itself plus something else, we can use string right here plus equals. This has the exact same effect. It is just a shorthand for what we had. So we are still creating a new version of bio that is the old version with this concatenated onto the end. Now, if we go ahead and rerun the code as it currently stands, we're going to get our likes appended. If I rerun node person, I get Alexis is 27. Alexis likes teaching. Alexis likes biking. Not the nicest way to structure that sentence, but for now it does indeed get the job done. For Clancy, there is nothing about his likes. It just says Clancy is 51. Now, what I want to point out here is the fact that we're able to use this inside of the function passed to for each. Why is that? Well, arrow functions don't bind a this value. So it uses whatever this value its parent has. The parent has the correct this value for the instance. We're able to access this.firstName up here. We're able to access this.firstName down below. If I switched this over to a regular function, the code would actually break. And we can prove that by adding the function keyword before the arguments and removing the arrow. Now, if we were to save things and rerun them, we would see some broken output. We have Alexis is 27, undefined likes teaching, undefined likes biking. So we're able to access this.firstName correctly right here, but down below, the this binding is broken by our regular function, so we're not able to access the instance properties. If we do want to access them in some sort of callback function, we need to use an arrow function, which does not bind this, allowing us to successfully access them. So that's where we're going to stop for this video. We covered a little bit of ground in this one. We learned how we can set up methods for the instances of our constructor functions, and that's allowing us to reuse code. We have the exact same two methods available to all instances of person. Now we're going to continue on to the very next video. The next video was originally going to explain exactly what's happening here, but since we did run a little over, I want to include a challenge. So we're going to have a challenge video up next for Hangman. Then we'll get back into exploring how this prototypal inheritance works behind the scenes. All right, I'll see you next time.